Let's define a simple list called names. To define a list in Python, we use brackets. As you can see, when I used the brackets, Python automatically filled in the other end of the bracket. Now this denotes a list in Python, a list of whatever you want, a list of names, a list of numbers, a list of grades, a list of ages. You can do whatever you want in here. Now, the first name in the list of names is going to be Bob. The second name is going to be Alice. And the third name is going to be Henry. Now that we've defined our simple list of names, what are we going to do with this list of names? Well, there are many things we can do with this list of names. We can access individual elements in this list of names, and that is called indexing. Now, indexing means accessing the individual values in the list. Now, when we talk about indexing, it's important to note that the first element isn't actually 1. So when we count this list, you don't go from 1, 2, and 3. In Python, you actually go from 0, 1, and 2. And it's not actually only in Python that this theory holds. It's actually in many other programming languages. The first element in an array in Java is 0. It's at index 0. And in Python, the first element in a list is at index 0. The second element is 1, and the third element is 2, and so on. It goes how long you want it to go. So, in order to access, for example, Bob in the list of names, you say names, and then you hit brackets, and then in here you pass a number, an index, and that index is the position of the value you want to get. So the position right here is the index. I want to get the index at 0 in order to get Bob. Now let's print this out to see what the output is. As you can see, we get Bob. We can switch this from 0 to 1 to get Alice, and we can switch it to 2 to get Henry. What if we go beyond the index to the third value right here that doesn't exist? What happens? We get an index error. This is something you want to avoid. You need to make sure you know the length of your list, and there are many ways to find out the length of your list. For instance, in order to find the length of your list, there is something called the length function. The length function. This length function is very useful when you're working with lists or anything in Python. A list, you can use it with strings, dictionaries, tuples, and sets. So I'll temporarily disable this print statement. I'll convert this to a comment. Let's use the length function to see how long our names list is. Now we need to print out the length function, the output, because nothing will happen if we don't. And in here we're going to pass in the list of names. Now, what would you say would be the output of this function when we print it out? Think about it. Now let's see. Yep, it's 3. If you guessed that right, give yourself a pat on the back. If not, let's see why. Now, you may have remembered when I said that the first element starts at 0. Well, when we're counting the length of the list, you actually start at how many individual elements are in the list. So you would say, oh, there's 1 element, 2 element, 3 element. And that's why the length function prints 3. The difference is when you're indexing, it starts at 0, 1, and 2. And it doesn't go on after that. When you're trying to find the length, the first element starts at 1. When you're trying to index, the first element starts at 0. So it's important to make that difference. Length starts at 1 and indexing starts at 0. Keep that in the back of your head as you work with lists. So the length function is a really powerful tool in Python, so its applications are widespread, and it's an important function you want to have in your toolbox. So now that we have access to this index here, what can we do? Let's print it out again to remind ourselves what it was. So as you can see, 3 is too high. So what we can do is choose any number that's between 0 and 2, because that's the length of the list. Let's go with 1. So we have Alice. Now I have a question for you. What is the data type of this value that I'm highlighting? Is it an integer? Is it a list? Is it a string? Is it a tuple? A decimal? What is it? Think about it, and let's see. Now to check this out using Python, there's a type function. This type function returns the data type of the argument that you give it. So let's print this out and let's see what it is. As you can see, names right here is a string. Why is it a string? Because Alice in the list is a string. Because Alice is a string, this value right here is also a string. So basically, this is equal to this. These two values are the same. This represents this, and this represents this. So this basically represents the value at index 1 in the list of names. So if this is a string, then that means we can use string methods. For example, we can use the title method. The title method returns a version of the string where each word is title cased. Let's see what that does. As you can see, we have a neatly capitalized first name, Alice. As you can see in the list, even though it wasn't capitalized, the title method capitalized and neatly formatted this string. We can also use the strip method. The strip method removes blank space on a string, on any side of the string. So as you can see, we have some spaces around the name Alice. Now if I didn't have the strip method, let's see how our output would look. As you can see, we would have some space that isn't taken care of around the name Alice, and this isn't a nice way to keep your data together. So if you know you have data that has spaces, strip it out. That way you have a neatly formatted string. We can also use the upper method and lower methods. Upper method makes it uppercase, the lower method makes it lowercase. Because Alice is a string, we can apply all string methods. So instead of using positive values when indexing, what if we used negative values? What do you think happens? Is that a possible way to accessing values from a list? Well, let's see. Let's say -1 in this case. Let's print it out. We get Henry. So names at -1 gives us Henry. So what Python is basically saying is that Henry is at position of -1. So if Henry's -1, then what position do you think Alice is? Well, that puts Alice at -2. If Alice is -2, what position is Bob in? Well, Bob would be in position of -3. Let's see if this works. So basically what this is saying is that if you want to index Henry, you can use the value 2, or you can use the value of -1. Let's try using -3 to see if we get Bob. As you can see, we do indeed get Bob. We can also use 0 and see if we still get Bob. We still get Bob. So basically, you can use negative numbers and positive numbers to access elements in a list. However, the same theory holds true, that you can't go beyond -3, because the length of this list is -3. So if we put -4 in this case, we get an index error. Always make sure to stay within the bounds of the length of your list. So the maximum length that we can go up to is -3. Now we're going to talk about modifying lists. What does modifying lists mean? Modifying lists mean changing specific values in a list. For example, in this case, why don't we switch the name Bob to Jack? How do we do that? Well, remember to use the equality operator whenever you're updating values in Python. Always use the equality operator. For now, let's print the original list. And let's see the before and after. So originally, this is how it looks. This is the original list. Now let's update the list. To update a list is very similar to how we index a list. So what we're going to do is names at position 0. We're going to switch Bob to Jack. And remember to use the equality operator. We're going to set it equal to a new string, a new name. In this case, it would be Jack. Now, if we just run this, nothing really happens. So we have to print out the after list, the new list. As you can see, the original list at position 0 is Bob, but the new list is Jack. So we've basically switched Bob behind the scenes. To us, this may seem like the names at position 0 is still Bob, but right here, we're updating it to Jack. Now we're going to talk about adding elements to a list. What if we want to add more names to the list of names? How do we do that? Well, there are two methods to do this that will help us to do this. The first one is the append method, and the second one is the insert method. Now I'll show you the difference between these two methods and what they can achieve. So to use and add value into the list of names, let's first use the append method. So let's say names.append. Now, the append method expects an argument. It wants the value you want to put to the list. So let's say we want to put Anna. Now let's print out the list. As you can see, everything else is the same, but we have a new value at the back of the list, and it's Anna. The append method throws whatever you give it at the back of the list, all the way at the end. That's what the append method does. Now, what does the insert method do? Well, let's see what it does. Insert method, it wants an index. So one of the arguments to the insert method is an index. Where do you want to put this value in? Let's say we want to put it between Bob and Alice. How do we do that? Well, that would be at position 1. That way, Alice would move to the next line, to the next position, and Anna could fit right here at the first position. So let's say 1. And we're going to put next is the object. What do we want to give it? Well, that would be Anna. Let's see how this list looks. As you can see, we have Bob, Anna, and Alice, and Henry. Anna is right between Bob and Alice. This is what the insert method does. Now, you can actually start with an empty list as well, and you can build your list over time. You don't necessarily have to have values in a list in order to add elements to it. So if we say names.append Henry, we get Henry as the first element. We can add more elements. Bob. And as you can see, Bob is thrown at the back of the list. We can do names.append Alice. And we have Alice. And we can do names.append Anna. So now we've built a list by just adding elements into the list. So this is how you add elements in a list. Now we're going to talk about removing elements from a list. how do we remove elements from a list? How do we remove names from the list of names? Well, similarly to adding elements, there are methods to removing elements as well. The first one was actually a keyword, and it's the delete keyword. The second one is the pop method. And the third one is the remove method. Now, how do we use each of these methods? Let's look at the delete keyword, for example. So the delete keyword deletes whatever you tell it to delete. So let's say delete. What do we want to delete? Let's say we want to remove Bob. And Bob is at names at index 0. Now let's print this list and see if Bob was removed from the list. And that's exactly what we see. Bob has been deleted from the list. If you delete something with the delete keyword, that is permanent. You can't undo it. This is a permanent deletion. There's nothing you can do about it once you remove it, unless you append it again. If you do names.append Bob, well, that way you can undo the deletion. But once you delete with the delete keyword, it's gone forever. Now let's look at the pop method. What does the pop method do? Let's see what it does. Let's do names.pop. I know it sounds funny, like you're popping something. In a way you are. Let's see what it does. Names.pop. Let's run it. Okay, so we have Bob, Alice, but Henry is missing. Henry was deleted. Henry was removed from the list. That's what this says. Henry was removed from the list. What's cool about the pop method is that it's, in a way, not permanent. How do you know if it's not permanent? You still can't undo the change, right? Well, in a way, you can actually save what is deleted. So we can say the name that was deleted. And why don't we print the name that was deleted? Let's see if that works. So we're setting name.pop equal to a variable called name, and we're printing that variable. Let's see what it prints. Oh, it prints Henry. So the pop method returns whatever it deletes to you, just in case you might need it. So once you pop the list, a value from the list, it returns it to you. And you have to save that in a variable, or else you can't have access to it. So the pop method by default removes the last element in a list. By default, it just deletes the last element and it returns it to you. Now, you can actually pass in arguments into this list. You can pass in an index to be more precise. What value at what position do you want to remove? Let's say we want to remove Bob again. So we do index 0. As you can see, Bob is removed from the list, but we still have access to Bob. He's not deleted completely. It's not permanently deleted. We can append it again. We still have access to Bob because the pop method returns whatever it deletes. Now, what if you don't know the index? What if this list infinitely goes on and on and on, and you know there's a name in that list called Bob? How do you remove that name Bob? You don't know what position it's in. In this case, you use the remove method. The remove method makes things really easy when you're trying to remove values from a list. The remove method wants a string. It wants what you want to delete. What name do you want to delete specifically? Well, if I want to delete Bob, I just write Bob in here. And this remove method will do the job of deleting the name Bob from this list. I don't need to give it any numbers. I don't need to give it an index. It will automatically delete the name Bob from the list of names. Let's see if that's true. As you can see, Bob is removed from the list. The remove method is permanent. Unlike the pop method, it doesn't return it to you. So once you remove it, it's done. It's out of the list forever. So these are the 3 different methods you can use to remove values from a list. Now there's a cool method I want to show you, and it's the index method. The index method tells you the index of the value you want. For example, what if I say I want the index Henry? What if I don't know what Henry is. What position is Henry at? Is he in the 3rd position, the 10th position? What position is Henry in? The names.index method does exactly this. However, you're going to have to print this out or save in a variable. You can just say index is equal to names.index Henry. This is going to return you a number, the position. So you can print this. You can print the index and you'll know what position Henry is in the list of names. So Henry is in the 2nd position. And we know that's true because the first element is 0, the second element is 1, and the third element is 2. So this is indeed correct. Sometimes you want to know what the index is of a certain value in a list. You can use the index method. Now we're going to talk about organizing our lists. How do you organize a list so it's neatly stored in the list? Well, there are a few methods to do this. The first one is the sort method. The second one is the sorted method. And the third one is the reverse method. These 3 methods allow us to organize our lists more neatly and in an organized fashion. So let's see what the sort method does. In order to use the sort method, we just drag this alongside the list of names. So you say names.sort, and that's it. You can give it a couple of Boolean arguments if you want, but we'll talk about those later. Now, let's print the list of names and see the changes that have taken place. As you can see, the sort method has changed the order of our list. And it's sorted alphabetically. If you notice, it goes from A, B to H. This is an alphabetically sorted list. And now that our list has been updated, this is no longer the original list. After we use this function, after we command the function to sort the list, this list will no longer be in this messy order. Now, the sort function doesn't only sort strings. You can actually put numbers in here. And you can say 1, 10, 13, -5, 4, and let's say 20. And we're going to say numbers instead. Now let's see if this sort method sorts this list of numbers. And as you can see, the sort method sorts this list of numbers from least to greatest. It goes from -5, 1, 4, 10, 13, all the way up to 20. What if we want to reverse the order of this sorted list? What if we want it to go from greatest to smallest? In that case, you can give it a Boolean value. You can say reverse is equal to true. Once you put this argument in here, then it reverses from greatest to least. Now let's go back to our original list of names. Now that we've seen that the sort method has taken place, and it does the same, you can also reverse this and it will reverse the order of the list alphabetically. Now the sort method is permanent. You can't go back to the original list of the unordered list of names. It's permanent, that's it. Once the list is sorted, it can't be unsorted again. However, let's talk about the sorted method and what it can achieve. The sorted method, as you can see, doesn't have a period. So you don't have to follow the list of names. You don't have to say it like this, names.sorted. This does not exist. Instead, what you're going to do is just say sorted, and you're going to pass in this parentheses names. Now that you've said names, you have to save it to a variable if you want to, or you can just paste it in the print statement and let's see what it does. It does exactly the same thing as the sort method, but the only difference is that it's temporary. How do we prove that it's temporary? Well, let's print the original list right after the sorted list. Does it go back to the original, or does it maintain the sort? As you can see, it's actually now different. It went back to the original order of the list. It starts from Bob again. So the sorted method is temporarily sorting the list. It's not permanent. So if you don't want to make permanent changes, use the sorted method. But if you want to use permanent, you can use the sort method here. Now let's look at the reverse method. Obviously, from what you can see, the reverse method reverses the order of the list. Let's see what it does on the list of names. Names.reverse. Let's print it. Let's see what it does. So let's print the names again. Hit run. As you can see, it reverses the order of the list itself. So we first started at Bob, right? And we go to Alice and we go to Henry. But in this case, we start with Henry, we go to Alice, and we go to Bob. That's what the reverse does. It doesn't sort it alphabetically, numerically, it just reverses the order itself. And this is permanent. Once it's reversed, it can't be unreversed. So these are the three methods of organizing our lists. These are powerful methods that you want to use and keep in mind as you work with lists in Python. These also extend to dictionaries, tuples, and sets. So these are widespread functions, and most of the functions we've discussed in this video so far also extend to other data types and data structures in Python and aren't limited to lists. Here is all the important information you need to take away from this video. I hope you received value from this video on the first part series of lists, and if you have any questions, leave them in the comments down below. Thank you for watching.